Great. Well, welcome to Stanford. You have a very exciting time ahead of you. And I want to tell you a little bit about, as Lee already teed up, one of the things we're doing here, which is linking up students with industry to actually do pilots. But I'm going to give you a bit of background about why did we choose these areas, which is to work on buildings, energy, transportation, and water. So I'm going to give you a brief introduction to that. And at the end, tell you just a little bit about NATO, which you can come see me about after you graduate. So why do we care about this area? Well, we've seen a dramatic shift in productivity in our civilization. Can anybody name what that event was? Not the computer, I'll give you that hint. The Industrial Revolution, exactly. The Industrial Revolution gave us 13 times the GDP per capita, doubled our life expectancy, meant that you are not all going to die at age 40, gave you about 100 times the energy at your disposal to do whatever you like, and basically gave us, for all practical purposes, too much food supply, not just unlimited, but actually so much that we wind up obese. However, we have not had that kind of revolution in resources. Resource use, as you can see, has gotten slightly more efficient over this time period, but nothing like the Industrial Revolution. How do we achieve that kind of productivity shift if we're going to go to 9 or 10 billion people on the planet, and we're going to want everybody to actually lead a good, healthy, middle-class life? Well, we have a couple problems. One is some of these resources are actually finite. We're not going to create more water on the planet. You can see the entire western half of the US already a year ago, but certainly even more, or 2 years ago now, even more acutely so now, is in severe drought condition. Structurally, because of the way our water rights system works. Climatologically, because we've had climate change that actually makes all of these drought problems worse. And then we've been incredibly inefficient in our use of water. We're actually growing alfalfa grass in the desert, in the Central Valley, and exporting it to China for them to feed to cows. Tell me how that makes any sense as a agricultural policy. But that's why we have water shortage. That's actually a global phenomenon. This is a balance of water supply and demand. Everything below the axis is shortage. You can see there's some pretty major civilizations on the planet that are structurally short of water. So this is an urgent problem we need to fix. Bringing it back to home level, what you eat matters a lot in this. You can see the amount of land, water, and energy required if you're a meat eater and you choose to eat beef is quite a bit more dramatic than if you eat tofu or you eat vegetables or even chicken. So think about that the next time you go out to eat. Food service, I understand, is working on this already, but I don't know. Your individual choice still matters. The second big issue is land use. This is a map of the Bay Area, and we have, for about 70 years now, placed jobs and housing in different locations in the Bay Area. Jobs have been near the water, near the bay, actually all the beautiful waterfront real estate. Housing has generally been along the old city centers, which were formed along the train line that Leland Stanford built and ran. And you can see this big mismatch. Why does this matter? Well, we've created our own last mile problem. And if you look at the data, people take transit if both their home and their workplace is close to transit. People are generally willing to walk half a mile. More than half a mile, not so much. You have to be an athlete or really into fitness or come from a different continent. If you go outside the US, people actually do walk more than a mile for their daily level of exercise. And you can see, particularly having your workplace near transit is really important, which is exactly what we haven't done. We've put all the workplaces into parking lots far away from transit. So we have a serious issue in our transportation. You'll find most of the cities along here, for those of you who are new to the area, have massive anti-growth movements. All the city councils have gotten turned over from people who are just anti-growth now, want to turn Silicon Valley into Detroit, and the reason is because they don't want traffic. They don't want more cars. Well, it doesn't have to be that growth equals more cars and more trips. That's an artifact of the choice that we've made on land use. Let me shift a little bit to the buildings themselves. This is a company up in Canada called Doing It Right This Time. They have come up with a modular way to basically replace a 150-year-old invention, which is the screw. If you think about a screw, it's a 22-dimensional device that destructively fastens one thing to another. It took about 150 years to standardize, took 2 world wars of the US supplying Europe to actually agree on what the standard dimensions for a screw were. But we haven't changed the screw in about 50 years now, or 70 years. And the screw is really kind of dumb. You cannot undo and reverse and reconfigure without actually having damaged the underlying material. Dirt invented this. Extruded aluminum, slide it in, slide it back out. Modularity at a much more granular level. Most people, when you think modular homes, think either trailers or cubicles. They've done these kinds of interiors, high-end lawyer offices, hospitals, with this system. You can actually build 30,000 square foot in a day. You can do it in an operating hospital environment without having to shut anything down because there is no sawing, drilling, or dust when you install this system. You can apply the same thing, and I don't know if I can run the video from here, so to an entire building. This is a broad sustainable building in China. No, they don't need the sound. I just need the, hopefully there is no sound. We can turn that off. This is a company that basically took modular manufacturing to building construction. And you can see they're building a skyscraper. Everything is lifted in by crane. All of the pallets that are arriving here by truck are built in a factory in a zero waste environment, in a highly controlled environment, so there's zero defects and zero waste. And if you're watching closely the day-night cycles, they're building the entire 30-story skyscraper in 15 days. This is actually an old video from last year. They've just finished a 57-story skyscraper, also in 15 days. So that's kind of unprecedented for the construction industry. Even more interesting is this is a Richter 9 earthquake-proof building with extremely high energy efficiency with all the modern conveniences and controls you'd expect. So we're not talking about low-end housing. I always get the question, yes, but it's an ugly block. Can you do something more architecturally interesting? And it turns out there is a company in Australia that's using these same techniques to build really cool, modern, curvaceous buildings. So that's just a choice of engineering, not something intrinsic. The other thing is you could take this building, disassemble it, move it somewhere else, add to it, which again is not how we run our built environment today, but would be a dramatic increase in resource productivity. A third of all our waste, and by the way, each and every one of you is responsible for 86 metric tons of waste per year. Did you know that? 86 metric tons. Most of it is in roads, buildings, infrastructure that gets built on your behalf. We could reuse it and change the way we operate. Let me talk about what I think of as the worst offender, where I'm spending most of my time these days, which is transportation. How many of you own a car? Okay. Show of hands, how many of you don't own a car? Excellent. You're the smart investors. Let me tell you why. Any of you who bought a car made a really dumb investment decision. You may have had other emotional reasons to buy a car, but it wasn't for smart investing. Here's why. Where's your car typically? Parked. Yes. It's parked 96% of the time. So great. You're getting 4% use out of your car, except for the detail that almost half of that time is stuck in traffic or looking for parking. So enjoy those activities in your car. It gets even worse when we look at the fuel equation. About 1% of the fuel that you're pumping in here in California at outrageous prices, almost $4 a gallon still, while the rest of the country has had lower prices. 99% of that turns into other expenses for you, entire brake wear, and in heat that we're pumping into the atmosphere to make our planet even hotter and make our room even hotter. So not exactly an efficient way to get around. It is also, for your age group, the leading cause of death. You're more likely to die in a car accident than gunshot wounds, drug abuse, or any disease that you can name. Why do we accept this level of death? We fly planes. Planes were more dangerous in the 20s than vehicles. They were actually more dangerous into the 50s. There was a plane crash over Long Island where two planes collided. We decided to have automation, air traffic control, rules, and stricter pilot training. We took airplane crashes down to now we kill about 200 people per year in plane crashes, which if you adjust for mileage, we drive about 4 times the amount that we fly. It would be 800 people versus 33,000. We're missing something in terms of how we drive. And now the kicker, infrastructure. Your grandparents and your parents have spent about 5% of GDP building transportation infrastructure in this country. We have a wonderful interstate highway system. We used to have a wonderful train system, not so much anymore most places. Massive investment. If you do the math, those freeways are loaded, best case, for about an hour or two in one direction, 5 days a week. At peak loading, when you don't have a traffic jam and throughput actually drops, right? So then they're not at peak, they're actually performing below peak. At peak loading, you've got a car followed by a space of about 7 or 8 car lengths. If you think about the utilization of that infrastructure, most of it is open, empty space that's just there because human reaction times are so long. You get 0.5% utilization out of this massive multi-trillion-dollar infrastructure spend. So that's why I think there's an opportunity here for resource efficiency. It's not intermodal transportation this way. This is a shot on 280 right outside the university here of a Muni vehicle being carried on a semi. This actually is the kind of intermodal transportation we need. This is City Mapper, a British startup company, and they combine different modes. Most of you have probably already taken Uber. Combining Uber, bike trips, shared car trips, Caltrain into one system, that's where we need to head. That's the kind of stuff that we do in the Energy Transformation Collaborative. It's actually students working hands-on with companies. We did a pilot with Caltrain to see if we could improve capacity on their trunk line schedule. We're doing a pilot that's still going on, trying to see if we can get the Dumbarton Bridge and align to Facebook and reconnect the bay between the BART side and the Caltrain side. And we did an amazing pilot getting Stanford employees who are commuting into campus but coming from more than 3 miles away. The under 3 miles, people generally walk or bike, but more than 3 miles, almost everybody drives, unless you're coming all the way from San Francisco. We gave them electric scooters and electric bicycles to shift. We got 1/3 of all their trips to actually shift to an electric two-wheeler mode, which has never been done anywhere before. It was incredible results. Most amazing is the videos, actually, which I didn't bring today to show because we have limited time. But people were so happy actually commuting by electric two-wheelers, saying, this is cool, I feel young, I feel hip, I'm having so much fun. So there's a joy in this mode of transportation. And what's fascinating is we found people would chain the trips. They would stick the two-wheeler scooter into their trunk, drive somewhere, and then actually take the scooter out to go somewhere that was hard to park at. And so, again, those combinations are where things get interesting. One thing you need to know, a lot of people will tell you transit only works with density. It's not correct. There are a lot of cities in Europe that are only 2 or 3 stories that don't have New York-style density. The real secret to getting transit to work is frequency. You can see here, most US cities are up here, 70, 80, 90% single occupancy vehicle share. The reason is they've got, and here's a blowout of that section, they've got 30 to 60 minute intervals. You go to San Francisco, which is actually a pretty well-performing bus system. Most off-peak times are still 40 minutes or longer. At 40 minutes, you miss one bus, your entire day's schedule is screwed up. Now, unless you happen to be retired or have a lot of time, that doesn't work, right? You look at well-performing transit systems, we've got some in the US, Washington, D.C., Boston, New York. City I grew up in, Vienna, actually has moved to 2-minute intervals now. At that point, you can stop thinking about transit times and departure times. You show up, you get on the next vehicle, you go. So it becomes a very efficient system. It's an important fact that we're trying to get through in our modeling and in our work with cities now. This is actually the bike pilot that I mentioned. You can actually see here in the data, this is your bike trip if you're taking a regular bike. You can see when you get to 10 miles out, it's pretty slow. It takes you almost an hour to get there. Here's your car trip in the commercial world that you see on TV, the car with no other cars around driving through the beautiful landscape. You've all seen those commercials. This is your car trip. 10 miles takes you about 12 minutes. However, this is your real car trip. You got to find parking. You actually have to drive in congestion. That 10 miles actually takes you almost 30 minutes. You now ride an e-bike, and you can see your e-bike's faster, then it becomes about the same time, and only really starts getting a little bit slower at 10 miles out. So up until about 9 miles out, electric two-wheelers are actually faster than getting in your car and driving around. They're also, as you can see on the right-hand side, less than half the price, even assuming we're all California wimps and get into a car and Uber and whatever during the rainy days, right? Which you all will do, trust me, because you get so used to the weather regardless of where you grew up. Here's the economics of ride sharing, which is another really interesting inflection point that's being bred here in California and spreading rapidly. This line is leasing a new car. This line is purchasing a new car. Either way, you've got a big capital expense up front. Owning a car is around $10,000 a year if you bought a decent car, a little bit less if you got an old used Honda Civic, a little bit more if you're buying a BMW. But you can see then the per mile cost is not too bad, right? It does increase because there's gasoline and maintenance, but the line is relatively flat. Here's the new business models, Uber, or if you're willing to share, Lyft Line or Uber Pool, or Drive Now. It's mostly variable cost. There's really not much cost to join these. In the case of Uber, nothing. In the case of Drive Now, it's a very nominal fee. The cost per mile is higher, but you can see the crossover point relative to leasing a car is about 5,000 miles. If you're actually willing to share the ride, it's about 10,000 miles. Now here's the data of the average amount of driving for US citizens. And you can see about half of driving in the US is under that 10,000 mile threshold. So remember how I said you made a poor investment decision? Unless you're one of these guys driving the 22% driving 15, 20,000 miles or more, which if you're studying hard at Stanford, I guarantee you you're not driving that much, then you shouldn't, for economic reasons, own a car. You might get pleasure out of it. It might be a status symbol. Might be other things for you in your life. But it's not an economic purchasing decision. So you didn't do it because it's cheaper. Where can this go if we fast forward a little bit? Well, we have Tesla building electric cars. We have Google building autonomous cars. We have Uber allowing us to share cars. And we have these new apps allowing us to actually integrate and be connected and understand where the vehicles are at any point in time and connect to transit. Well, that's all very exciting, but that's still only sort of version 1.5. The real future of transportation is start putting these together. And you have to realize the combined effects get much, much better. If I have sharing and autonomy, suddenly the car can come to me. I don't have to pick it up anymore. The infill trips, I don't need a driver in the car anymore. 60% of the cost of Uber is the driver. I can get rid of that if I have autonomy. If I have electric cars, they can go recharge on their own when I'm not using them. All parking in a city would disappear. Parking is about 25% of real estate. Imagine you own 25% of San Francisco or New York land and could redevelop that. We can put it to parks, we can put it to new residential space, housing here in the Bay Area. Amazing things we can do with our cities. The combined effect takes you from about 60 cents to $1 today, depending on what kind of car you drive, to about 8 or 9 cents per mile all in. Suddenly, the 50% of our unemployment that is because people can't get to jobs can actually afford to get to their job at 9 cents a mile. This is going to happen in your lifetime, and you can come be a part of developing these kinds of solutions in our class. I'll show you a little bit about how to apply in a second. Just to trigger how radical this is, if you think about sharing, suddenly we can go beyond the 5 seats in a car. I always have to have the same kind of car. I can change cars and configurations based on my trip type. Already beginning to see that the rear seat actually matters more because that's the person who's paying, right? Rather than the guy who's in the front seat right now driving. If you go to autonomy, there isn't a front seat. There's a really cool startup from the autonomous vehicle team here at Stanford called Zoox. They're working up at SLAC. They're making a car that actually can go either direction, can just reverse direction. Because once you have no driver, you don't have a steering wheel. What's the meaning of having a front and back, right? That's just a relative to the direction of motion at that moment in time. You can obviously also change what you make your money on. In fact, BMW did a calculation. They make more money on a car they put into their Drive Now sharing system than they do selling a car to you outright. Selling a car to you actually is not a very profitable business. It's about $1,000 of profit on a $40,000 car. I can make more than $1,000 of profit putting that car into ride sharing every single year. So again, all the assumptions we've made about how transportation has to work are changing in this decade in your lifetime. I'm going to skip this. This is about solar and why there was a meteor strike in solar. You can see solar costs coming down. And just close and give you a chance to ask questions. This is our course. Andy Karsner and I will be teaching this this fall. And basically, we're looking for people interested in working on these topics. And we have a very specific site this fall that we're working on these topics on, which is East Palo Alto, an area that has a lot of challenges. East Palo Alto has the most junior water rights of any city on the peninsula. And those of you who've been following the news, even the senior water rights are now getting cut because of the current drought. So East Palo Alto will not have water for industry or for residents. How do we solve new solutions to recirculate the water to efficiency? East Palo Alto has very high power prices, doesn't have a community solar program yet. How can we make the buildings more efficient? How can we actually deploy renewable energy technology? And then it is a transit desert. There's no rail line. The bus systems that go through actually cut through East Palo Alto without a stop. You can take the Dumbarton Express, doesn't stop in East Palo Alto. And there are very few other modes of transportation. And a lot of people can't get out of East Palo Alto to get to jobs because there's no public transportation. How do we solve these problems on an integrated basis with new solutions? We spent a lot of time last year, as I showed you, developing individual solutions for Caltrain, for bikes. We want to now actually put them together in one community and see how far we can take it. So if you're interested in this, come join us. We want you to send a short statement of purpose and a little bit of your background. And then you get to work together with other students and with the mayor and city manager of East Palo Alto and a number of interesting tech companies that are developing these solutions. So I told you I was going to tell you just 1 minute about what I'm spending my time when I'm not on campus on. Notto is basically building the data infrastructure and system for this vehicle world that I showed you of autonomous shared vehicles. So we have a computer vision, machine learning based approach to actually make all vehicles smarter as a retrofit upgrade that you can put even into your old Honda Civic. You don't have to actually buy a new car. Do I still have time for questions? All right, let's do a couple. Yes, there in the back, please. And then we'll come up here.
So I read Resource Revolution and loved it. I read about a year ago. It was really inspirational. I'm really interested in water, and I just started at Stanford Business to really pursue that vision. But I'm talking to a lot of VCs, a lot of people in the business world, and they're saying water is like solar 15 years ago or 20 years ago in terms of business. So what have you seen in terms of a potential entrepreneur who wants to get into water? Why would you have hope for that person? And what advice would you give them to be successful in business in water?
Well, you like a challenge because I agree that water is the toughest of these spaces. The advice I have is either pick an industrial vertical that cares about water quality as well as water cost. So the semiconductor industry is a great example. Purity matters. A single atom of copper can destroy your entire microprocessor. So that's an industry that has paid for very new water solutions because purity matters. The other option is to go outside the US. Water in the US is municipally funded. Municipalities don't make their own decisions. They hire outsourced engineering contractors and consultants to give them advice. Those people are paid to be conservative. They would never recommend a new solution. We're stuck fundamentally. About half our communities are not in EPA compliance for water requirements today. No one's punishing those cities because the cities would go bankrupt if they were punished. So getting new technologies adopted in the US is very, very tough. I'd go overseas to where new cities, new infrastructure is being built. And there's a lot of companies now actually looking at water solutions for many of those emerging market regions that I showed you that are structurally, chronically short of water. They're willing to pay for water because if you live in a rural community in Africa or India and you're spending 4 or 5 hours a day getting fresh water, you're actually willing to pay a reasonable amount of money to get fresh water locally in a purified way. So good luck to you. I think it's a fantastic area, but it's not an easy one. Yes, here, and then we'll jump back here.
You have a slide on public transportation and frequency of it. But one of the questions I have is when you start increasing the frequency, essentially who pays for that and what happens to the capacity loading factor? Because I mean, one of the reasons, for example, Houston has a much longer time is people still use it. It's not efficient. So how does Indiana work? It's a smaller city. How does that work?
Yeah, so there is a chicken or egg problem. Do you add the capacity first or do you have ridership first? We're never going to get spontaneous ridership on systems that are inconvenient. So we have to start on the capacity side. So yes, we do need to fund that. We actually fund lots of other things as municipal projects. We just need to make this a priority. As to your question about do you just automatically get it with capacity increase, with frequency increase? I've simplified a little bit. That is, I think, the key driver, but obviously your route design, how convenient your payment systems are, the quality of the vehicles, all of those factors matter a lot. But if you look at most US transit projects, we spend 95 or even 98% of the money on the tracks, on the land, on the infrastructure. The vehicles are always an afterthought, and yet that's what actually matters to the experience, right? The brilliance of Uber was actually reinventing the experience of riding a taxi, not reinventing the vehicle or reinventing the roads or reinventing infrastructure, right? That's where we need to focus. So it's not the only solution. There's some really interesting work on the grid design. Most US transit systems measure by geographic coverage. What percentage of the population is within a short walk of a stop? Irrelevant. You need to have the high density routes that a lot of people take to capture a lot of ridership rather than do a little bit of service for everybody. That doesn't make any sense. So there are other factors that I've simplified in that chart, but yes, please.
I'm from the BSB. I was thinking the kind of principle applied to road transport, making it more smarter, increasing the utility of existing infrastructure. Have you ever thought about applying those principles to, let's say, other sectors, for example, sanitation, and for that matter, water, which Derek was talking about. So even in countries which are, in which these sectors are municipally controlled or single government controlled, how can we make them like more efficient? For example, the transmission sector, for that matter, is idle for like 30% of the time during the peak hours and off-peak hours. So while we are talking about distributed solutions in here, so have you done any research on centralized solutions? How can we make this one?
So I have, and the book that Derek mentioned, Resource Revolution, that I wrote, is about that applied to a broad range of industries. You can see that in food, you can see that in agriculture, you can see it in civic infrastructure, information services. So yes, it applies broadly. We basically have focused so much on labor productivity and on capital sheet, balance sheet restructuring, where we've outsourced stuff, offshored stuff. We really haven't thought through asset turns and system level productivity. And that's the lens we should be applying, because actually for most industries, assets are a big part of the total cost structure. And if I get low utilization of assets, I've locked in a high cost structure. Right? That's the reason why for 2 decades Southwest has made money in an industry that otherwise has been absolutely shitty. Right? All the other airlines have lost money until recently, when they basically have jacked fares up enough and reduced enough capacity that now they're all making money. But that was all about asset turns of getting more value, more mileage out of the planes. And that same principle can be applied in a large number of industries. You touched briefly on a governance challenge. That's a very local issue of how to really get the governance and the government interaction to be more efficient. And I don't have a single universal answer there. I think that's very different in India versus China versus here in the US. So, last question. Back there. So that's an extremely good question. Like, I don't know if any of you heard. The question is, how can you avoid displacement of the local population when you're trying to do these infrastructure improvements? Historically, we've mostly ignored that, right? There's a number of books on Robert Moses in New York plowing freeways right through lower income neighborhoods. Generally, here in California, we've done better than that recently in the last decade. We've retracted a lot of freeways and made improvements. It's a big issue as we start tackling East Palo Alto, right? How do you not just reduce a whole bunch of low-income housing to build another mode of transportation? So I think there's a couple levers as part of that. One is this idea of actually increasing the asset turns. So make the existing assets work more. We have an existing rail line that runs all the way through East Palo Alto and then over the bridge to Union City. That rail line is now being used for, I kid you not, rock storage. Union Pacific stores balancing ballast stones and rails there. That's all it's doing. It has no utilization, has no utility to the local population. So we want to rebuild that line, have a bike trail, have a railroad on it again, and be able to have high-frequency passenger traffic. Part of the challenge for this fall actually is to integrate things so that you can improve water, energy, transportation at the same time. Because it's pretty easy to get your improvement in one of those by making the rest harder. And that's what we've historically done a lot, where we've said, look, we're just going to get more water by drilling holes in the ground and pumping a lot of water. Sounds like a great solution for a year or two until the groundwater level drops, until we realize we spend 20% of our energy in California moving water around, and we don't have that much energy either. So that's where it gets really interesting in terms of having to actually come up with a system solution. So that's why these problems are hard. I don't have a kind of silver bullet answer to here's the only way to do it, but you actually have to look at exactly those issues to really make it better. So thank you very much. Good to meet all of you, and enjoy your time.